Welcome YouTubers to another episode in my Grammar Hero series. In today's video, I'm going to be working out the mathematics knowledge practice test questions from the third practice test on my website. In case this is your first time finding my YouTube channel, I quickly want to mention that I recently created a small website called ASVABapp.com. There you can take 3 short practice tests as well as 3 full-length practice tests, and each of them gives you an estimate of your AFQT score. In order to get the most out of this video, you have 2 options. You can either go to that website and take the practice test there, or if you're going to use this video on YouTube to take this practice test, I strongly encourage you to pause the video after I read each question, attempt to work out the question on your own scratch paper, and then resume playing the video to check your solution. On the ASVAB, you're not permitted to use a calculator or a reference sheet. So regardless of where you take this practice test, try not to use any of those resources. As usual, there's going to be timestamps in the description of this video. Those timestamps are going to be associated with each question. Next to the timestamp, there's going to be the topic that the question's testing, as well as a link to a video in which you can learn more about that topic. So if at any point throughout this video you feel as if you need more help, just take a look in the description, and there you'll find those additional resources. So all that being said, let's go ahead and get started with today's video. All right, this first question says, simplify the expression. We have 5 times parentheses 482 minus 82, close parentheses, plus 100 divided by parentheses 3 plus 2, close parentheses squared. So for this one, we're going to have to make use of the order of operations to simplify this expression. In case you haven't seen those in a while, order of operations are best remembered by the acronym PEMDAS, and this stands for parentheses, exponents, multiplication, division, addition, and subtraction. What's more, this tells you the order in which you simplify expressions like this. That is to say, you work out what's in parentheses first, then you do exponents. After that, you do multiplication and division as they appear in the expression from left to right. That is to say, those have equal precedence. And then finally, you do addition and subtraction as they appear from left to right. Likewise, those have equal precedence too. So with that in mind, let's go ahead and copy down this problem over here. We have 5 times 482 minus 82. And it's a good idea to get in the habit of writing down these questions on your own, in as much as you're only going to have scratch paper on the actual ASVAB. And let me grab my pen here. Okay. So if we look through our expression, you can see that we do have 2 sets of parentheses. We have 482 minus 82, and then we have 3 plus 2. So according to the order of operations, we're going to take care of what's in parentheses first. So let's do that as our first step. 482 minus 82, that's just going to leave you with 400 plus 100 divided by 3 plus 2 is 5. Okay. All right, we've taken care of what's in parentheses, so let me go ahead and cross that out. Now we're looking through our expression for exponents, and we're going to address those accordingly. As you can see, we only have 1 exponent in this expression, notably 5 squared. So let's go ahead and deal with that next. This is 5 times 400 plus 100 divided by 5 squared is the same as 5 times 5, so that's going to be 25. All right, so we took care of all the exponents in our expression. Now we have to look for multiplication, division, addition, and subtraction. We have 5 times 400 here, which is multiplication. We have addition here and division here. According to the order of operations, we do multiplication and division as they appear from left to right, and we do those before addition and subtraction. So right here we have 5 times 400. Let's go ahead and take care of that. 5 times 4 would be 20, and just tack on those 2 extra zeros. So 5 times 400 is 2,000. We have plus 100 divided by 25. And as you can see, we now have two operations left in our expression, notably addition and division. Of course, division comes before addition, so we're going to work out this division first. This becomes 2,000 plus 100 divided by 25 is 4. And now we just have addition left, so we'll go ahead and do that. 2,000 plus 4 is 2,004, which is answer choice C. So again, you will see problems involving the order of operations on the ASVAB. Make sure you know how to apply them as you simplify expressions. All right, number 2 says if x equals 3 and y equals negative 2, determine the value of the following expression. And we have 2x plus 5y in parentheses times 5x minus 3y in parentheses. So let's go ahead and start by copying this one down. We have 2x plus 5y times 5x minus 3y. So for this problem, you have to understand how to substitute values into expressions and then simplify them. Again, we're going to be substituting in 3 for x and negative 2 for y. So now that we've written down the expression, let's go ahead and substitute those values in. This becomes 2 times 3 plus 5 times negative 2 times 5 times 3 minus 3 times negative 2. All right, and again, we're going to follow the order of operations as we simplify this expression. So that said, we're going to work on what's in parentheses first, and let me put the order of operations up here real quickly. Again, please excuse my dear Aunt Sally, our PEMDAS. As you can see, we have two sets of parentheses. We have one here and one here. Inside this set of parentheses, we have multiplication, addition, and multiplication. Of course, we know multiplication comes before addition, so we'll work on that first. Likewise, in this set of parentheses, we have multiplication here, and subtraction here. So we're going to do the multiplication first and then the subtraction. So let's go ahead and work on simplifying this a little further. This is 2 times 3, which is 6. 5 times negative 2. A positive times a negative is going to be a negative. So this is minus 10. Let's simplify this one. 5 times 3 is 15. Negative 3 times negative 2 is positive 6. Again, a negative times a negative is a positive. And as you can see, we only have one operation left to perform in these parentheses. So let's go ahead and take care of that. 6 minus 10 is negative 4. 15 plus 6 is 21. And let's keep working this out. Again, we have a negative times a positive, so we know our result's going to be negative. We have 21 times 4. 1 times 4 is 4. 4 times 2 is 8, so this is negative 84. All right, so this was kind of a test of your ability to substitute values in, as well as to follow the order of operations to simplify the expression. Okay, so pretty good question there. And OneNote updated on me recently, so it doesn't scroll as well as I'd like it to. So just bear with me there. All right, number 3 says 28 is 40% of what number? Personally, I love these questions because it tells you exactly what to do. Let's work on translating this word problem into an expression. We have 28. In math, is equal, so we're going to put equal above is. 40%, we're going to express that in decimal form, which is 0.4. Of is multiply, so we'll put multiplication right here. What number? That's an unknown value, so let's just represent that with n. So if we rewrite this right here, this says 28 is 40% of what number? So 28 equals 0.4 times n. So for this one, all we do is have to solve for n. And that's not that difficult to do. As you can see, it's going to require one step to do. Notably, we're going to have to divide both sides by 0.4. This will cross out over here, leaving you with n equals 28 divided by 0.4. I'm going to do that off to the side. We have 28 divided by 0.4. We're doing long division involving a whole number, notably 28, as well as a decimal, notably 0.4. The key to doing this one is understanding that you can do long division involving decimals as long as that decimal's only inside this division bracket. Since we have a decimal outside the division bracket, we're going to have to make some adjustments before we proceed. And the very first thing I'm going to do is put a decimal right here and a 0 placeholder. And let me just explain this. 28 is the same as 28 with a decimal, and you can put as many zeros as you want. Again, those values are equivalent. But that said, in order to do this long division, I'm going to get rid of this decimal place outside the division bracket by shifting its decimal one time to the right, and that's going to prompt me to shift it a corresponding number of times inside the division bracket. So this becomes 280 divided by 4. And as you can see, we cleared the decimals by moving them a corresponding number of times outside and inside the division bracket. Now that we've done that, we can perform this long division as we normally would. We start by asking ourselves, how many times does 4 go into 2? Doesn't. How many times does 4 go into 28? It goes into 28 7 times evenly. But that said, since there's a 0 here, I can just bring it up like this. And this says 4 times 70 is 280 with no remainder. So we can see n is 70. And of course, in math, it's customary to write the variable for which you solved on the left. So n equals 70. Again, this says 40% of 70 is 28. So this one is 70. Not too bad. A lot of people would get tripped up right here, which is the point of these videos. Again, I understand a lot of people don't use long division on a daily basis, but once you get the hang of it, it's pretty easy to deal with. All right, number 4 says if P is 1/4 plus 1/5 plus 1/20 times 0.38 plus 0.9573, then the value of P is between which of the following numbers? So not surprisingly, I'm going to start this one by copying it down. We have 1/4 plus 1/5 plus 1/20 times 0.38 plus 0.9573. All right, so for this one, we're going to have to be mindful of the order of operations as we work this one out, notably PEMDAS. And as you can see, we have two sets of parentheses. In this set of parentheses, there's only addition, so there's nothing to worry about there. In this set, there's only addition, so there's nothing to worry about there. So we're going to work out what's in parentheses first, and then perform this multiplication next. That said, you can see we're dealing with fractions here. More specifically, we're dealing with the addition of fractions. In case you haven't dealt with fractions in a long time, you should realize that you have to have fractions with the same denominators in order to add them. In this case, we have a denominator of 4, 5, and 20. So my first goal is to rewrite these fractions such that they all have the same denominators. And that's not too difficult to do in this case. Again, 4, 5, and 20 share a common factor of 20. So we're going to rewrite all these fractions such that they have new denominators of 20. To write 4 as 20, we would multiply it by 5. And we're also going to do that to its numerator. 5 times 4 is 20. 5 times 1 is 5. To write 5 as 20, we multiply it by 4. And we're also going to do that to its numerator. 5 times 4 is 20. 1 times 4 is 4. This one's already in the correct form, so we're just going to copy it down as is. And we'll just copy this down for now, but we'll deal with this in just a second. Again, we're going to do one thing at a time here. All right, let's move down a little bit. All right, so now that we have fractions with the same denominators, all we do is have to do this. It's all going to be over 20, and it's going to become 5 plus 4 plus 1. Okay, 5 plus 4 plus 1 is 10, so this becomes 10 over 20. We can cross out these corresponding zeros. 10 over 20 is 1/2, and 1/2 in decimal form is 0.5. Okay, we're going to make use of that information in a little bit just to work it out. Let's deal with this addition of decimals over here. That's pretty easy to do, so let's work on that. Let me get my scroll wheel here so I can move to the right a little bit. Let's go ahead and add these off to the side over here. We have 0.9573 plus. I'm going to place a 0 in front of that decimal. I'm also going to place a 0 there, plus 0.38. And likewise, I'm going to put some 0 placeholders right here in case we need them. 3 plus 0 is 3, 7 plus 0 is 7, 5 plus 8, 8, 9, 10, 11, 12, 13, carry a 1. 9 plus 3, 9, 10, 11, 12, plus 1 is going to be 13. So we're going to drop down a 3 and carry a 1. Drop down our decimal in place. 1 plus 0 is 1. Okay, so this becomes, and we can jump right here, this becomes 1.3373 times 0.5. Again, the key to this one is to know that 1/2 is 0.5, so you can quickly work this out. And now we're just multiplying decimals here. We have 1.3373 times 0.5. In order to multiply decimals, you want to get rid of the decimals completely. So in 1.3373, I'm going to shift its decimal place 1, 2, 3, 4 times to the right. And in 0.5, I'm going to shift its decimal place 1 time to the right. So in total, I shifted the decimal 5 times to the right. And now we're working out this problem, 13373 times 5, albeit with 5 decimals to shift back into the left at the end when we're done. 3 times 5 is 15, carry a 1. 7 times 5 is 35, plus 1 is 36, carry a 3. 3 times 5 is 15, 16, 17, 18, carry a 1. 5 times 3 is 15, plus 1 is 16, carry a 1. 5 times 1 is 5, plus 1 is 6. Bring our 5 decimals back in. 1, 2, 3, 4, 5. Okay, so we can see that 0.5 times 1.3373 becomes 0.66865. And let's take a look at our answer choices now. And we're looking for a value between that 0.66865 fits in. This is 0 to 0.1. This is 0.1 to 0.25. This is 0.5 to 0.75. And 0.66 fits in between those, so we know this is the correct answer. Again, to be successful on the ASVAB, you have to understand that it's pretty easy to convert decimals to fractions. And for these very simple ones, you should be able to do it as quickly as I just did. Again, 1 over 10 is 0.1, 1/4 is 0.25, 1/2 is 0.5, 3/4 is 0.75. Okay, so pretty challenging problem in as much as, I forced you to work with fractions and decimals at the same time. All right, number 5 says solve the expression for x. We have 50 minus x minus 3x plus 2 equals 0. So let's copy this down. We have 50 minus x minus 3x plus 2 equals 0. And we want to solve for x. Well, the very first thing we have to realize is that there's technically an imaginary 1 here, which means we have to take this negative and distribute it to this 3x as well as to this 2. So let's go ahead and do that. This becomes 50 minus x. Negative 1 times 3x, again, that's a negative times a positive, so that's going to be negative 3x. Negative 1 times positive 2 is going to be negative 2 equals 0. Now we can simplify this now that we've gotten rid of these parentheses. Negative x and negative 3x is negative 4x. And 50 minus 2 is plus 48 equals 0. Again, we're solving for x, so in other words, we want to get x by itself. So the next thing I'm going to do is subtract 48 from both sides. This becomes negative 4x equals negative 48. Divide both sides finally by negative 4 to get x by itself. In this case, we have a negative divided by a negative, so we know our result's going to be positive. 4 divided by 4 is 1. 8 divided by 4 is 2. So this is B positive 12. Okay? And that's that one. All right, number 6 says solve the following system of equations. We have 2x minus 3 equals negative 12. Then we have x minus 2y equals negative 9. So I'm going to start by copying this one down. We have 2x minus 3y equals negative 12. X minus 2y equals negative 9. So as far as solving systems of equations go, there's 3 options that you have. You can either use the substitution method, the elimination method, or linear algebra or matrix algebra. Since most people don't learn about matrix algebra in high school, we're going to talk about either the substitution or elimination method. And in this case, it's going to be the easiest to use the elimination method. And that says multiply one equation by a constant such that it enables you to eliminate either the x or y variable. And in this case, if I multiply this bottom equation by a constant of negative 2, when I take this negative 2 and distribute it to all the variables in parentheses, this will become negative 2x plus 2x, which will be eliminated. So that's what we're going to go with here. Again, we're going to take this negative 2, distribute it here, here, and here. So let's copy down this top equation as is. And let's start distributing this negative 2. Again, negative 2 times x is negative 2x. Negative 2 times negative 2y is positive 4y. And negative 2 times negative 9 is going to be 18. Again, negative times a negative is a positive. Now that we've rewritten this bottom equation, we're going to add the 2 equations together. And negative 2x plus, or 2x plus negative 2x is eliminated. Again, that would be 0, so it's gone. Negative 3y plus 4y is just y. And then we have negative 12 plus 18, which is just going to be 6. Okay, so we solve for y at this point. Once you solve for one of the variables, you're going to take the value of that variable and plug it into either of the 2 original equations and solve for the missing variable. So here are our original equations. We have 2x minus 3y equals negative 12. Then we have x minus 2y equals 9. I'm going to plug this into the second equation where we have x minus 2y equals negative 9. Again, we now know what y is. Y is 6. So we're just going to plug in 6 in place of y. This becomes x minus 2 times 6 equals negative 9. This is x minus 12 equals negative 9. We're solving for x at this point, so we're going to add 12 to both sides. This crosses out, and this leaves you with x equals 12 plus negative 9. Again, that's going to be 3. So the answer to this one is x equals 3, y equals 6, or as an ordered pair, that's going to be 3, 6. Again, in ordered pairs, this is your x and this is your y. So the answer to this one is B, of course. All right, number 7 says, write the equation of the line that passes through the point -2, 6 and has a slope of 3. So again, we have this point -2, 6, and we know our slope, our m. Again, m is always going to be slope when you're dealing with equations of lines of 3. In my view, the easiest way to solve this one is to plug these values into the point slope equation. And again, that's this y minus y1 equals m times x minus x1, where y1 and x1 refer to the values of the ordered pair that you're given, and m, as I just mentioned, refers to your slope. Again, we can regard this as x1, y1. So let's start plugging things in. We have y minus y1, which is 6, equals m. M is 3. X, we're just going to copy down. X1 is -2, so this is minus -2. Let me point out that when you have minus minus like this, it just becomes positive, okay? Now, the very first thing I'm going to do is take this 3, distribute it to this x and 2. So this becomes y minus 6 equals 3 times x, which is 3x. Then we have 3 times 2, which is 6. So this is plus 6. Again, we want to get this equation such that we have it looking like this. Y equals mx plus b. That's the equation of a line. So we're going to add 6 to both sides now. This crosses out here, leaving you with y equals 3x plus 12. We don't see that as an answer choice, unfortunately. But if we look right here, we can add 12 to both sides. This will cross out, leaving you with y equals 3x plus 12, which is the same thing as we came up with here. So the answer to this one is D. I just moved the 12 over here to see if that would throw you off a little bit. So hopefully it didn't. But, you know, got to do what I got to do to make these a little bit tricky. Number 8 says, solve the following quadratic equation for r. We have r squared minus 2r minus 4. And this hint says if you can't factor this equation, you may need to use the quadratic equation or quadratic formula. So let's start by copying down this equation that's given. We have r squared minus 2r minus 4. No matter how hard you try, you're not going to be able to factor this one. And likewise, since we have these plus or minus square roots as answer choices, that should be a clue that you're going to have to use the quadratic formula to simplify this or factor it or solve it, however you want to phrase that. And again, quadratic formula is this: negative b plus or minus square root of b squared minus 4ac all over 2a. And you might be saying to yourself, well, where do I get BAC from? Well, again, quadratic equations are of this form: ax squared plus bx plus c. Technically, there's a 1 in front of this r squared, so our a is 1 in this case. Our b is going to be -2, and our c is -4. Now that we've identified those values, we can simply plug them in and solve accordingly. Again, b is -2, so this is -2 plus or minus the square root of -2 squared minus 4. A is 1 and c is -4 all over 2 times a is 1. All right, so the very first thing you want to address is this double negative. Double negatives become positive, so that's just 2. So this becomes 2 plus or minus, and we can work out the denominator very quickly. 2 times 1 is just 2. Let's deal with this square root now. 2 squared is 4. -4 times -4 is going to be positive 16 times 1 is just 16. So this becomes 4 plus 16. And now we have 2 plus or minus the square root of 20 over 2. Unfortunately, that's not one of our answer choices. So there's probably something we can do to simplify this square root 20. And in fact, there is. This is the same as 2 plus or minus the same square root of 4 times the square root of 5. Again, square root of 20 is the same as the square root of 4 times 5. If you know your principles or properties of radicals, you can then split this to be square root of 4 times the square root of 5, which I just did right there. Of course, the square root of 4 is 2, so this becomes 2 plus or minus, again, the square root of 4 is 2 times the square root of 5 over 2. We can factor out a 2 from this numerator, so this becomes 2. We're factoring that out. 1 plus or minus the square root of 5 over 2. And then we can cross out these that we factored out. So this is 1 plus or minus the square root of 5. So that's that one. And that would be answer choice A here. Okay, so pretty challenging in as much as you had to know, one, the quadratic formula, quadratic equation, and then you had to be able to simplify these radicals using the properties of radicals. And we're going to see another problem later in this video in which we have to simplify radicals. So there will be more on that shortly. Let me go ahead and get rid of this right here. All right, number 9 says the radius of a circle is 1/2 centimeter. What is the area of the circle? So in this case, we're dealing with a circle, and we're told what its radius is. Again, radius is always the distance from the center point of the circle to the edge of the circle. So this distance that I just drew right here is 1/2 centimeter. We want to find the area of this circle. Area of circles is always given by the formula area equals pi r squared, where r, of course, stands for radius. So let's go ahead and start working on this one. And you're going to have to know this formula for the ASVAB, absolutely. And what's more, you're always going to have to know that pi is going to be approximated as 3.14. Okay, so in place of pi, we'll go ahead and write 3.14. Radius was 1/2, so we'll plug that in for r squared. All right, so to do this one, we're trying to figure out what 1/2 squared is. And that's the same as 1/2 times 1/2. That is to say, you have to multiply these fractions together. When you multiply fractions, you multiply straight across. So this becomes 1 times 1, which is just 1, and 2 times 2, which is 4. So 1/2 squared is 1/4. So this becomes area equals 3.14 times 1/4. One's in a decimal and one's in a fraction. So I'm going to convert this fraction to be in decimal form. And that's not too hard to do. Again, we should know 1/4 is the same as 0.25. And now that we've done that, let's go ahead and work this off to the side. We have 3.14 times 0.25. Again, we're multiplying fractions here. So the goal is to get rid of the fractions so that we can perform the multiplication, and then we'll add them back in at the end. So we're going to shift the fraction in 3.14 2 times to the right, and likewise we're going to shift the decimal. Did I say fraction? We're going to shift the decimal in 3.14 2 times to the right, and likewise we're going to shift the decimal in 0.25 2 times to the right. So in total, we shifted our decimal place 4 times. This becomes 314 times 25, albeit with a total of 4 decimal places to shift back into the left at the end when we're done. Let's go ahead and work this out. 4 times 5 is 20. So we're going to drop down a 0 and carry a 2. 5 times 1 is 5 plus 2 is 7. 3 times 5 is 15. Before we start multiplication with this 2, we have to add a 0 placeholder. 2 times 4 is 8. 2 times 1 is 2. 3 times 2 is 6. Add these together. 0 plus 0 is 0. 7 plus 8 is 15. Carry a 1. 5 plus 2 is 7 plus 1 is 8. And 6 plus 1 is 7. Bring our 4 decimals back in. 1, 2, 3, 4. So the area in this case is 7,850 centimeters squared, and that is answer choice C in this case. Okay, so that's that one. Make sure I still have my pen here. I do. Number 10 says solve the following inequality for x. We have 3 times x minus 4 minus x plus 1 less than or equal to negative 12. All right, I'm going to say this right off the bat. The only hard part about dealing with inequalities is this. When you multiply or divide across this inequality sign by a negative, it flips the direction of the sign. Otherwise, the direction of the sign doesn't change. You can add and subtract across it. But again, if you multiply by a negative or divide by a negative, across it, it flips the sign. So with that in mind, let's go ahead and work on this one. We're going to have to distribute this 3 to this x and to this negative 4. And likewise, there's technically a negative 1 here that we have to distribute here and here. So let's work on doing that first. This becomes 3 times x, which is 3x. 3 times negative 4, which is negative 12. Negative 1 times x is negative x. Negative 1 times positive 1 is negative 1. Again, this is less than or equal to negative 12. Let's combine our like terms. We have 3x and negative x, so that's going to be 2x. And then we have negative 12 and negative 1, so that's negative 13. Again, that's less than or equal to negative 12. Again, we're solving for x, so let's add 13 to both sides as our next step. This crosses out here, leaving you with 2x as less than or equal to negative 12 plus 13, which is just 1. And again, we're going to divide by a positive across the inequality sign, so it's not going to change its direction. This crosses out here, leaving you with x is less than or equal to 1/2, which is answer choice A. Okay, so again, if you're adding and subtracting across the inequality sign, no worries. If you're multiplying and dividing by a negative on just one side of the inequality sign, no worries. But as soon as you divide or multiply by a negative across the inequality sign, that's when you have to flip its direction. All right, number 11 says find the mean, median, mode, and range of the following. We have 13, 18, 13, 14, 13, 16, 14, 21, and 13. The very first thing you should do when you're asked to find the mean, median, mode, and range is to arrange the values that you're given from least to greatest. So in this case, 13 is our smallest value, and it appears 1, 2, 3, 4 times. So it's going to be 13, 13, 13, 13. Then we have 14 twice, so that's 14, 14. Then comes 16, 18, and 21. All right, now that we've done that, finding the range, median, and mode is a lot easier. Let's start by working backwards. Again, the answers are ordered like this. This is the mean. Again, the mean comes first in the question. This is the median. This is the mode, and this is the range. So I'm going to start by finding the range first. And range, in case you forgot, is the biggest value in your data set minus the smallest value. Now that we've ordered these from least to greatest, this is pretty easy to figure out. The biggest value is 21. 21 minus 13. Of course, that's going to be 8. And as we can see, all the ranges in our answer choices are in fact 8. So that's a good start. Again, we're working backwards here. We found the range. Now we're going to work on the mode. And as it happens, the mode is the number that appears the most often. And whereas 13 appears 4 times, all the other numbers appear once or twice. So our mode in this case is going to be 13. Mode here is 13. Mode here is 13. Mode here is 15. Mode here is 13. So we know C is not a viable answer choice. All right, now let's find the median. Now, to find the median, you cross off numbers 1 at each end until you get to the middle term. If you have an even number of numbers in your data set, you're going to have to find the average of the two middle terms in your data set to find the median. But let's just start working on this one. We're going to cross off one here, 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 and one here. So we can see our median in this case is 14. Just going to call this median right here. I'm not going to write that legibly. So we have a median of 14 here, median of 13 here. So we know this is incorrect. And we have a median of 14 here. So as it happens, our answer choice is either going to be A or B. And the only other thing we have to find is the mean. To find the mean, and this takes the most amount of work, you have to sum all your data points and divide by how many data points there are. So this is going to be 13 plus 13 plus 13 plus 13 plus 14 plus 14 plus 16 plus 18 plus 21. We're going to divide by how many data points there are. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 data points. Okay. So let's get started doing this. Let me see if I can move over here so I can do this one. All right, so when I have to add up a lot of things like this, I'm going to choose to do it vertically. So I'm going to do it like this: 21, 18, 16, 14, 14, 13, 13, 13, and 13. All right, and this isn't as bad to do as you think. We got 3 plus 3, which is 6. And then we have 3 plus 3, which is 6. 6 plus 6 is 12. 4 plus 4 is 8. 8 plus 12 is 20. Then we have 8 plus 1, which is 9. 9 plus 6, which is 15. 20 plus 15 is going to be 35. So we're going to drop down a 5 and carry a 3 here. And this side's really easy to do. We have 3 plus 2, which is 5. And 1, 2, 3, 4, 5, 6, 7, 8. So this all here is 8. This is 5 plus 8, and that's going to be 8, 9, 10, 11, 12, 13. So this is 135 over 9. Let me go ahead and scroll back over here. So this becomes 135 over 9. There's a trick to decide whether this is going to be divisible by 9 evenly. If you sum all the terms in 135 and it's also divisible by 9, you know that 135 itself is going to be divisible by 9. So 1 plus 3 plus 5 is 9. 9 is divisible by 9. So I know 9 is going to go into 135 evenly. And again, this is long division here, so this becomes 135 divided by 9. And we ask ourselves, how many times does 9 go into 1? It doesn't. How many times does 9 go into 13 without going over? That's 1 time. 1 times 9 is 9. 13 minus 9 is going to be 4. And then we drop down this 5. 9 goes into 45 5 times. 9 times 5 is 45, so there's no remainder. So the mean in this case is going to be 15. And let's go ahead and pick the appropriate answer choice. If I can scroll over there, that's going to be answer choice D in this case. Okay, so that's that one. All right, number 12 says the height of a triangle is 4 inches more than twice the length of the base. If the area of the triangle is 35 square inches, what is the height of the triangle? So this question doesn't specify what type of triangle we're dealing with. So I'm going to draw a right triangle, which I enjoy working with more often than the other types of triangles. So this is going to be our right angle here. To find the area of any triangle, you're always going to use the formula area equals 1/2 times base times height. In a right triangle, your base is here and your height is here. Okay. That said, those aren't that obvious to figure out in this problem. We're told, what's more, that the height of the triangle is 4 inches more than twice the length of the base. So if I call this base x, that means the height here is 4 inches more than twice its length. So that's going to be 2x plus 4. All right. And let's go ahead and plug those things into this area equation over here. We're told that the area of the triangle is 35 square inches. So in place of A, I'm going to put 35. Again, 1/2. The base is x, and the height is 2x plus 4. Again, it's twice the length of the base plus 4. All right, so the first thing I want to do is take this x and distribute it here and here. This becomes 35 equals 1/2. And x times 2x is going to be 2x squared. X times 4 is 4x. All right, the next thing I'm going to do after that is distribute this 1/2 here and here. So this is 35 equals 1/2 times 2x is just x squared. 1/2 times 4x is just 2x. All right, now that we've done that, let's go ahead and bring this 35 over here via subtraction. This becomes 0 equals x squared plus 2x minus 35. And now this is a quadratic equation that we can solve, which will tell us what x is. And if you look back at our diagram, if we figure out what x is, we can plug in that value for x and find its height. So let's go ahead and solve this like we normally would. To solve this quadratic equation here, we're going to do so via factoring. And now we're looking for two factors that multiply to negative 35, but add to positive 2. That's going to be plus 7 and minus 5. Again, 7 times negative 5 is negative 35. 7 minus 5 is positive 2. And again, these are both set equal to 0. Again, I just moved that 0 to be over here. Not that big of a difference. When you solve quadratics like this, once you get to this point, you break them apart and set them both equal to 0 separately. I'm going to do that over here. We have x plus 7 equals 0, and then we have x minus 5 equals 0. Let's go ahead and solve these separately. Let's subtract 7 from both sides here. This crosses out. This says x equals 0 minus 7, which is negative 7. Let's go ahead and solve this one for x. Let's add 5 to both sides. This says x equals 0 plus 5, or just 5. Again, we're talking about real distances here, notably heights and the length of the base. So those values are not going to be negative. So we can get rid of this one right here. So we know x is going to be positive 5. Now that we know what x is, we can find the height by substituting 5 in for x here. This becomes 2 times 5 plus 4. 2 times 5 is 10, plus 4 is going to be 14. So the height of this triangle is 14 inches, and we had to use some basic algebra as well as the formula to find the area of a triangle to figure this one out. Pretty difficult problem, but again, this is basically Algebra 1 plus geometry that you learned in middle school. So again, that's the key to understanding the ASVAB. You're not going to deal with a lot of super advanced math, but it's going to take things that you learn in very basic algebra and very basic geometry and combine them into one problem, which makes it a little challenging. So that's that one. Number 13 says, simplify the following expression and write your answer in scientific notation. We have 4 times 10 to the third and 2 times 10 to the sixth. So let me copy this down to start. We have 4 times 10 to the third times 2 times 10 to the sixth. All right, so the key to doing this one is to break these apart. We're going to do 4 times 2 over here. Then we're going to do 10 to the third times 10 to the sixth over here. I have a video on scientific notation in which I explain this. So if you need help with what I just did right here, go ahead and watch that video on scientific notation. 4 times 2 is pretty easy to do. That's going to be 8. But here, we're multiplying numbers that have the same bases, notably 10, but different exponents. So to do this one, we have to be familiar with the laws of exponents, specifically the product rule. And the product rule says this: if you have a to the m times a to the n, that's the same as a to the m plus n. So in this case, we have 10 to the third times 10 to the sixth. We have the same bases, but different exponents. So this becomes 10 to the 3 plus 6. This becomes 8 times 10 to the 3 plus 6 is 9. And just like that, this is written in scientific notation. 8 times 10 to the ninth is right here. Okay, so that's that one. Number 14 says simplify the expression. We have 52x to the sixth over 13x to the seventh. So I'm going to copy this one down. We have 52x to the sixth over 13x to the negative seventh. Right off the bat, we should realize that 52 over 13 is 4. Again, that's division. 52 divided by 13 is 4. So we just took care of our whole numbers. And as I keep mentioning, you can never have a negative exponent. So let's just look at this x to the negative seventh. Again, we have 1 over x to the negative seventh. You cannot have a negative exponent. Whenever you have a negative exponent, that prompts you to move it across the division bar and make it its exponent positive. So 1 over x to the negative seventh is the same as x to the 7. Okay? So if we rewrite this, this becomes x to the sixth times x to the seventh. Again, technically, that exponent, since it's negative, should move this to be x to the seventh like that, and you can disregard it down there now. Okay, so now we're just dealing with the product rule again. Again, the product rule is a to the m times a to the n equals a to the m plus n. And that's what we have here. We have 4x. These bases are the same. They're x. So we're going to add their exponents, 6 plus 7. 4x. 6 plus 7 is going to be 13. So this reduces to 4x to the positive 13, which of course is d. So that's that one. All right, number 15 says simplify the expression. We have square root of 5 times the square root of 10 over the square root of 2. So let's copy that down. We have the square root of 5 times the square root of 10 over the square root of 2. And let's try to simplify this. If you know your properties of radicals, you know you can rewrite this square root of 5 times the square root of 10. That becomes the square root of 5 times 10 over square root of 2. Square root of 5 times 10 is the same as square root of 50 over square root 2. And now we can break this down such that we get a whole number. Again, the square root of 50 is the same thing as square root of 25 times 2 over square root of 2. And let's break these apart. This is the square root of 25 times the square root of 2 over the square root of 2. And let me scroll down here a little bit. A square root of 25 is going to be just 5. So this is 5 square root 2 over the square root of 2. And we could just go ahead and cross out these square root 2's. And this just becomes 5. Okay, so this one is C5. Got to know your properties of radicals to simplify them, and they're not that hard. When you have two multiplied by each other, you can combine them, and then you can work on simplifying them such that you get a whole number and can cross out a corresponding radical in the denominator. So that was the key to this one. All right, finally, number 16 says 4x minus 8 over 6 divided by x minus 2 over 3. So let's copy this one down. Let me go ahead and get rid of this off to the left here. All right, so we have 4x minus 8 over 6 divided by x minus 2 over 3. All right, so in this case, we're dealing with a set of algebraic fractions. So we're going to treat them like algebra and fractions. Well, when you divide fractions, you follow the algorithm keep, change, flip, or KCF. That is to say, this division here is the equivalent of this. You're going to keep this top fraction the same. That's our keep. So that's 4x minus 8 over 6. Change means you're going to go from division to multiplication. And this F or flip refers to this second fraction in the denominator. Instead of being x minus 2 over 3, you're going to flip it such that it's 3 over x minus 2. All right, so now that we've done that, we can work on simplifying this. Let's go ahead and simplify this right here. 4x minus 8. What can we factor out of that? We can factor out a 4 such that this becomes x minus 2. So now we have 4x minus 2 times 3 over x minus 2, and this, of course, is over 6. We can cross out these corresponding x minus 2's here. This will just leave you with 1 down here. So this becomes 4 over 6 times 3 over 1, which is multiplying fractions now. So this becomes 4 times 3, which is 12, over 6 times 1, which is 6. 12 divided by 6 is 2. So the answer to this one is A, 2. Okay, so again, algebraic fractions, you follow the rules of fractions as well as the rules of algebra at the same time. And ultimately, your goal is to simplify the expression. So, all right, so that's it for today's video. The only difficulty I had was with scrolling on this new OneNote platform, which is terrible in my view. As always, I hope you found this video helpful. And in light of that, you're more than welcome to leave feedback in the comment section below. I want to stress this. Every formula I mentioned in this video and every concept I touched on in this video is pertinent for the ASVAB. So you may have to work on committing some of those things to memory, such as the order of operations or the formula to find the area of a circle. If you like the content I'm creating, please consider subscribing to my channel. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.